So I had originally planned to do all of the examples in one video, and I made a mistake in one of the examples. So I apologize for the awkward transition, but it was probably better to break this into 2 videos anyway, so you had a chance to take a break. Our second example is not much harder than the first. So let's get back into the product rule. Derivative of y with respect to x is a slightly new notation. Instead of y prime, we did the d over dx, but this one is just saying derivative of y divided by derivative of x. That's what the d's are standing for. So we're going to add that in. And then we're going to use the product rule. So first, the x squared plus 3x minus 8, I pre-highlighted that in red, times the derivative of the second, which is in green parentheses. So the derivative of that is 5, plus the derivative of the first, which will be 2x plus 3 times the second. Now we do have a little bit of multiplying out here, so this one's a little debatable whether the product rule or multiplying it out first and using the power rule, how much difference the amount of work is. We do have some distributing, so we'll get 5x squared plus 15x minus 40. And then with the foiling, we'll get 10x squared minus 12x plus 15x, and then minus 18. Now I did multiply that out completely, showed all of the different steps, because at this point we have to combine like terms anyway, so we get a final answer of 15x squared plus 18x minus 58. And for now, with these, stick with doing it with the product rule to get good practice, especially with these that are a little easier. We're going to do 2 more examples, and these examples will have fraction exponents and also negative exponents. Remember with these to use the tools that are available to you to help with these questions. So for this one, again, we're going to use this newer notation, dy over dx, if we haven't used it already. And then the only other thing I would do in advance of doing that is probably rewrite this as x plus x to the 1/2. I'm going to squeeze that in before I actually do the derivative steps. And you always want to change those fraction exponents over, because you want to work with that power rule. So change your radicals into your fraction exponents. This is my first parentheses in red, and then my second in green. So we're doing first times derivative of the second. Sorry, so the derivative of the second is going to be 4x minus 5 plus derivative of the first, so 1 plus 1/2 x to the negative 1/2. We've seen that one a decent amount of times. Times the second, keep that consistent. And we do have some foiling on here with the fractions. Don't freak out just yet. These ones do have a little bit of that extra algebra going on. This should be x to the first here. This also should be x to the first. That will help us. So when I do 4x times the x here, I'm going to get 4x squared minus 5x. And then when I do the 1x to the 1/2 times 4x to the first, we're adding those together. So if I do 1/2 plus 1, I'm getting 3/2. Again, use the tools that you have available if you're not good with the fractions and adding and multiplying. And then I'll get 5 minus 5x to the 1/2. Something that you can do to line these up, if it works, then on my next one, I'm going to do plus 2x squared. So I'll try lining them up. If they don't line up perfectly, that's okay. Minus 5x, so far looking really good. And then the 1/2 times 2 is going to be plus 1x. If I do 2 minus 1/2, in this case, or negative 1 plus the 1/2, I'm also going to get the 3/2, so not lining up really nicely. And then minus 5/2, x to the negative 1/2 plus 1, which is 1/2. So I did run out of horizontal space, but it allowed me to line up the like terms here. That might not always work out, but it does on this one. So I'm going to get 6x squared. If I did want to put this in descending order, then the next thing that I would get would be plus 5x to the 3 over 2. You don't have to put it in descending order. Just realize, like, if you were doing that, the 3 over 2 was bigger than the 1, so I kind of did flip-flop these two guys. Then I'll have minus 10x, and then minus 15 over 2. Again, use the tools that you have available for the subtracting with the fractions there. If you want to do it with common denominator, that would have become negative 10 over 2, and you would combine them. So this is our final answer. Notice I waited on doing anything with the negative exponents until after multiplying it out because they went away when we did our adding. So don't make things back into fractions and make them foiling more complicated until you're done and you're at the end and you can move it. Same is going to be true with our last example, which will have our negative exponents. So we'll go back to f of x for this last one. This one actually, the negative exponents are actually a little bit easier to work with because you're just adding negative numbers. So I saved a slightly easier one for last. First thing, always rewrite it like we did with the previous one. So radicals change to fraction exponents, and then these fractions will change into negative exponents first before doing our derivative. We'll again highlight this is my first parentheses in red and my second parentheses in green. So product rule first times derivative of the second, which will be 2x minus 3x to the negative 4. Remember, it's becoming a bigger negative number, plus the derivative of the first, which is a nice derivative. It's just 1 because there's a 1 in front of the x here, right? Times the second. So I'm not changing the second. Again, at this step, check to make sure you have your first and your second parentheses preserved in each spot, and then you have either or derivative next to it. Now we are going to be foiling on the first one with the negative exponent, so you can bear with it. It's a little bit more challenging because of that. We'll get 2x squared minus, now this is x to the first, so minus 3x. If we're adding the exponents, it's going to be x to the negative 3. Then we'll have minus 18x plus 27x to the negative 4. We did the hard part because now we're just distributing in 1, so that keeps these the same. The only thing I might put in front of each of those are coefficients of 1 to make the combining like terms easier. We're almost there. We'll combine like terms and then move over those negative exponents. So this and this will combine to give me 3x squared. After that, if I want to keep it descending order, then minus 18x would come next. Then I have the plus 1x to the negative 3 and the minus 3x to the negative 3. So that'll be minus 2x to the negative 3. And then the last one doesn't combine, so minus 27x to the negative 4. So after you do this product rule right up here, there is going to be, for certain questions, that extra simplifying that you will need to do, and a few extra steps when you have the radicals and the fractions. Just because on this one in particular, we have to move our negative exponents back down to our denominators of our fractions. And then the fraction exponents have their own fun where you're adding, subtracting fractions. So a couple extra steps than you would have had previously on the ones that were just your nice integer or whole number exponents. All right, so that wraps up our examples. You'll now have a chance to try some practice either right after this or in the next class, depending on when you're watching these videos.